years ago, we moved to a little village in a national park near Budapest. It had the ideal school for our children and the kind of fairy tale tranquility the whole family had been looking for. We wanted to build our own house, in fact a passive house, one which, if it worked out optimally, would need no heating. Working on the design for the house was an exciting period, full of creativity. We sat down with the architect and discussed everything, the kind of house we wanted, what kind of rooms it should have, and how they should connect. My wife, Reka, asked only one thing, that everything to do with her should be on one level. And we had another important request. The house should blend into the surroundings of the forest edge. It was after we had applied for planning permission that we got the standard model. What had looked good on paper was suddenly less attractive. The segmented eaves and the triangular skylight were interesting but very conspicuous. We asked the architect for a simple, regular roof, but it was a compromise he found unacceptable and we parted company. Fortunately, he consented to another architect carrying on the design, on condition that his name should not appear anywhere. The roof, exterior facade and windows were changed. We got a new planning permit and finally, building could start. First, we had to turn the land from a hillside forest into a building site. This involved removing incredible amounts of soil, possibly 1,000 cubic meters, before we got a level surface or grade. Then we came up against the biggest risk factor in any building project: rain. April brought torrential rain. As soon as we called out the bulldozer, the sky clouded over, and just as it moved its first shovelful, the rain started pouring. This 2-day task took 5 weeks to complete. 1 month into our schedule, we had already lost a month. After we dug out the ground for the cellar, we had to lay the underground probes to bring up heat for the heat pump. This meant drilling 2 holes of 80 meters deep. The drilling rig came from Austria. I hardly dare tell the operator he was going to be drilling into a hill of almost solid rock, but Hans was delighted. His machine loved pulverizing any stones that got in its way. Plastic pipes were then threaded into the holes, making up U-shaped probes. The rocks in the deep underground strata are always at a temperature of about 12 degrees. In winter, the antifreeze fluid running through the probes heats up to about 4 degrees before it goes into the house. Whenever we need heating and hot water, we get heat out of this at 50 degrees by the magic of the heat pump. In the summer, the same system goes into reverse and cools the house. But as we will see, this house hardly needs any heating or cooling in any season. The next step was to mark the outline of the house. This is a crucial stage, to put it mildly. There are horror stories like the multi-story block in Buda, which ended up so far out of place that it stuck out into the street. That blunder is eternally commemorated by a neat S-bend. This is the extreme, but errors of half a meter or more are quite common. So I saved my comments when the main contractor's almost insufferably precise site manager checked the position of the house corners for the 3rd time. After the marking out, the excavators dug the foundations, and there we encountered the second risk factor: nature. Preliminary geological tests showed the site to lie on solid, dependable volcanic tuff. Laying the foundations should have been routine, but instead of tuff, the excavations revealed expansive clay, the most insidious of soils which, whenever it gets wet, swells with a force that can lift the whole building. And then they found an enormous rock running right under where one corner of the house would stand. To be sure that the ground under the building would be absolutely stable, the foundations had to go down beyond the 80 centimetre planned to reach the point where the soil moisture is constant. In some places, this meant 3 meters. We used more concrete for this alone than is usually needed for a whole house. I pleaded with Peter, the structural engineer. He was immovable. If you put in ordinary foundations, he said, the expansive clay will break your house in two. So, just to get firm ground, truckloads of concrete disappeared into the seemingly bottomless abyss. Only then could we lay the actual foundation. Before laying the foundations, we placed the main wastewater pipe where all the drains from the house will flow into. This ran partly under the concrete and partly through it, so we could not use ordinary wastewater pipes that fit into each other. All buildings move, and if a connection comes apart, you can't get through the concrete to repair it. So we used welded plastic pipe, an amazing invention, very resistant and incredibly easy to put together. My friend Gabor, a wise man from the village who does just about everything, put together the drainage system with my 7-year-old son, Mario. Despite being plastic, it is actually environmentally friendly. There is so little waste. Even a 10-centimetre piece can be welded to the next section. All we had at the end was a bucket full of cuttings. Gabor is almost excruciatingly precise and checked he had got the gradient right over and over again. The pipes rest on a bed of sand so that no sharp stones can damage them. The strip foundation is a highly reinforced concrete structure known as a truss beam. Since it partly stands out from the ground, it had to be poured into formwork. Instead of the usual pine planks, we used steel shuttering, which gives a nice, precise shape, is quick and easy to assemble, withstands the pressure of the huge bulk of concrete, and can be reused without limit. A house that has no heating needs insulation to the point of excess. It started here, in the foundations under the ground. The concrete was 10 centimetres thick, covered with polystyrene panels that can withstand the pressure of water and soil. After the strip foundation, there was more earth to be moved. A level grade had to be prepared within the foundations to pour the floor slab lined underneath with 10 centimetres of gravel. The Germans call this the sanitary layer because it prevents dampness under the house from seeping into the concrete. Water is probably the biggest threat to a house, attacking from above and below and all sides. Since our house was being built on a hill and just on the side of a trench that channeled enormous torrents of rainwater, we had to proof it from below against more than damp. It had to be ready for an onslaught of water at pressure. So a layer of waterproofing was placed on the gravel with 5 centimetres of blinding concrete just to give it a smooth, hard surface. Waterproofing is a special membrane of plasticized PVC with a carbon filler which stretches to follow the natural movement of the building. As well as stopping the water getting in, it acts as a barrier to the carcinogenic radioactive gas radon which occurs so commonly underground. We got an amazingly precise and efficient team of youngsters from a nearby village to lay the sheeting. They welded the pieces together and put on special sleeves wherever it passed over pipes or ironmongery to exclude the slightest chance of water getting in. The children look for the tiniest stones under the sheeting, anything that might puncture it when the heavy concrete spread over it. At a later stage, the PVC was welded to another sheet which rises up vertically to block the path of incoming water. This meant we could go without a trench full of gravel around the building. The water that runs down the hill and pours along the side of the house is caught in a drain pipe wrapped in geotextile and laid in gravel. This takes the water away from the house. That completes the waterproofing and drainage system. We used the same kind of pipes in the living room foundations. After the waterproofing, the final layer before the walls went up was the reinforced concrete base slab, which bears the weight of the whole house. The reinforcing steel was specified in type and quantity by the structural engineer and covered at all points by at least 2 to 3 centimeters of concrete to prevent rust. All poured concrete was compacted with a rod vibrator. This spreads it out smoothly and makes it compact and free of bubbles. It was the end of May. It had taken 2 months to make the basement foundations. The concrete monster supporting the strip foundations with their 10 centimeters of insulation, then 5 centimeters of concrete holding the waterproofing sheet, and finally the 15 centimeter thick reinforced concrete base slab. So the walls began to go up, starting at basement level. Attila, the general contractor, uses what looks like Lego bricks to build houses, even passive houses. These polystyrene blocks are actually forms for the concrete poured into the center. Here, for the basement, we also put in steel reinforcement bars. When the concrete sets, the polystyrene stays where it is, insulating the wall. Polystyrene is one of the best heat insulators you can get. The 50 centimeter thick blocks making up our walls keep in 5 times more warmth during the winter than a lightweight brick wall of the same thickness, and 11 times more than if it was made of ordinary concrete. Of course, you can put polystyrene insulation onto brick and concrete too, but these blocks snap together with hairbreadth precision and hardly any waste, and a whole story takes less than 2 days to build. It's child's play. If you've ever built anything of Lego, you could build a house with these. Since the architect didn't believe in right angles for walls, all trades had to put in an unbelievable effort to solve the resulting problems. These started with fitting together the blocks. If the walls had met at right angles, this would have involved just a simple bond that would have easily withstood the pressure of concrete. With all these acute and obtuse angles, the polystyrene had to be mitered at every corner, and the formwork had to be supported by all kinds of hooks and crooks. Above the cellar is the concrete floor of the bedrooms. To make it, we built up formwork of wooden beams and a kind of timber shuttering similar to chipboard, mounted on precisely adjustable steel supports. This put a mirror-like surface on the underside of the concrete that needed only the lightest touch of plaster to finish it off. The formwork had to support the enormous weight of the floor, 40 metric tons in all, or nearly 500 kilograms per square metre. Oiling the surface of the shuttering made it easy to remove it from the finished concrete.
Így van. És ez egy fürdőszoba, és itt végig áll.
On top of the floor slab formwork came the heating pipes. The house hardly needs any heating, and my own skepticism is the only reason it is there. Before we started building, Reka got me to visit several working passive houses in northern Germany during a snowy December. I saw with my own eyes there wasn't any heating in them, but since I had not met anybody who had built a passive house in Hungary, I was scared our insulation might not be good enough. What if my children got cold? So we put in lots of heating pipes, first here, then in the walls. Unlike floor heating, where the heat goes up, ceiling heating directs the warmth downwards. The water in the pipes takes energy from the heat pump at just the temperature it needs. So it heats in winter, and in summer gives cooling that is ridiculously cheap. The steel reinforcements were placed strictly according to the plan worked out by the engineer. In order to bury the cabling for the ceiling lights in the concrete, we placed conduits among the rebars. I have had terrible experiences of conduits being squashed under poured concrete, requiring a brand new concrete floor to be immediately cut open. So here we used concrete-proof gooseneck tubing. Another thing I have often seen is electricians struggling to pull wires through empty conduits. I had what I thought was a new idea. I pulled 3 wires through the conduit before it was laid. Not long after, I came across a French product which was just what I thought I had invented, but ready-made and to a slightly higher standard. Then came the high-strength concrete. Since it was mixed under blazing sunshine, a retarder was added to make sure that there was no loss of quality. And that was the cellar finish. Since the interior of a passive house is hermetically sealed and we do not want to lose heat by opening windows, it needs some mechanical ventilation. The first step in installing the ventilation system was when my friend Gabor and I laid a 50-metre long plastic pipe 2 metres under the ground. The air passing through it takes on the temperature of the ground, cooling in the sweltering summer and warming up in the frosty winter. We buried the pipes, including the branch that carries the air out of the house, and ran down the earth to prevent subsidence. Driving the compactor was like trying to steer an enraged bull. Proceeding up the hill, we came to the living room, also at the second level, but with no cellar underneath. It was the second of 3 phases, coming after the cellar and before the garage. Building on a steep slope meant doing the foundations, walls, and insulation separately in each phase, which all took a lot of extra time, energy, and money. Digging foundations is usually a one-off operation. We thought we would never see the back of the excavators, and after the cellar block was built, they could only get in via a long detour through the forest. The strip foundations for the living room had the same specifications as for the cellar, but this time we used timber formwork instead of steel and learned how much more work that involved. The second level comprises the living room and the rooms over the cellar. This time, there was no steel reinforcement required in the concrete because, unlike the cellar, the walls don't have to withstand the pressure of the ground. It's possible to lay even 2 stories without reinforcement out of these polystyrene blocks. Our wall was up within a day. The blocks for the interior load-bearing walls have 5 centimetres of polystyrene on each side. The system has all kinds of special components, so that laying the reinforced concrete crown was child's play, and there were spaces to get the height exactly right. We were ready for the roof, which was to be fixed to the wall with enormous purlin screws. Attila and I drove in these screws as the late summer sun shone down. It was a glorious September. What a feeling it was! The house had dried out, and if we got the roof on, all we had left was the interior work and we'd be done. Thought I was going crazy. 2 days before the prefabricated roof was to arrive, we had a downpour. A torrent of water rushed into the building, which became a kind of accidental swimming pool. All this rainwater was not going to go away by itself. We had to get a pump in. First we fixed the lowest horizontal beams of the roof truss to the purlin screws. Then came the laminated timber beams to hold up the roof of the terrace at the side of the house, beams so strong we only needed 3 of them. The whole roof truss is made up of prefabricated wooden triangles. It was not what we had originally intended, but we had been building for 6 months, and with the usual structure of reinforced concrete floor and rafters, we would not have got a roof over our heads before winter. So in order to get things moving, we opted for this prefabricated timber truss. The trussed rafters are computer designed and made under factory conditions. At each joint, there is a metal connector plate pressed into the timber on each side. The trusses arrive on site, ready for the crane to lift them into place. They are economical on material and very quick to fit. It was a huge delight to see the whole roof take shape in just one working day. Our waterproofing expert advised us to cover the whole roof with board or sarking. It was all down to the architect's imagination. Vapour always gets under the roof tiles and condenses on the vapour barrier underlay. Then it usually just flows off. But as our house did not have right angles, this condensated water would have flown onto the counter battens. So we laid these in right angles on the sarking. A good roof protects against summer heat as well as the rain. So we chose a cold roof, which means we did not use the attic space. And we included a wide ventilation slot in the sarking a little below the peak. The attic is well ventilated even on summer days, preventing the house from warming up. The sarking had a titanium zinc drip edge, glued on top of the waterproof but vapour-permeable underlay, which is stapled to the facade. This membrane protects the roof timbers from any condensation running down under the tiles, and it also protects the roof insulation from above, stopping any deterioration there. Counter battens fixed to the underlay on a spongy protective tape leave an air gap of a few centimetres between the underlay and tile battens, allowing the air to flow freely. From then on it was the usual arrangement, first the precisely spaced battens and then the tiles lifted onto the roof with a special hoist. These tiles are a good deal bigger than usual. They also absorb incredibly little moisture. This is important. Not only is a soaked tile very heavy, a sudden night frost can split it apart. Ventilation tiles keep the air flowing underneath, and snow catchers stop snow from hurtling off the roof if there is a sudden thaw. Then there's the punctured sheeting which stops the wind blowing snow powder under the ridge tiles in a storm. We couldn't find a factory-made peak tile, but the roof carpenter Bollage is a man for whom nothing is impossible. He made the peak tile himself, using standard tiles and special adhesive. We spent October drying out. That was when I understood that what takes time in building is not so much doing the work as waiting for the water used in the previous phase to dry. Water had been brought in by bucket or pipe or concrete pump, and there was a lot of it. In laying the concrete alone, we used more than 100,000 litres. The work continued inside the house with the partition walls. We did not go for what you might call traditional materials here either. I fell in love with a system of 10cm thick plasterboard panels that sort of zip together. You can build walls with them with incredible speed and such precision they don't need rendering. This saves work, lots of time and useful floor space because mortar would have made the walls 2 to 4 centimeters thicker. It is a solid wall, giving it good acoustic insulation, and it also makes a great contribution to humidity control. Plaster easily absorbs vapour, and then if the air gets too dry, it releases it just as easily. The partition walls were joined to the ceiling by gluing with polyurethane foam. Before getting started on the interior work, the site manager had a very important task: to draw the 1 metre line, the point of reference for the height of everything else. This is the line that all trades adjust their heights to, letting the builder of the partition walls know where to put the door cases, the electrician the sockets, and the plumber the sink and the toilet. The building really started to look like a house when the windows came. I had spent a long time chewing over what windows we should have. It's not enough to have fantastically insulated walls if the windows are substandard or not fitted in properly and the heat gets out. Originally, I wanted to have solid wood windows, but found out that wood can't give the level of insulation demanded for a passive house. The mechanical engineer worked out that if we used very high quality wooden windows with Krypton gas-filled triple glazing, we would still lose 600 watts more than passive house approved windows. 600 watts is approximately 3/4 of what an average toaster consumes. That decided the matter for me. What we got were real wood windows, but made of Meranti and fitted using a new technique specially designed for passive houses. I thought putting in a window meant squeezing some foam all around, screwing them in, and that was that. In fact, 4 separate materials are involved, providing insulation inside and out, and protecting the window cases against water and condensation.
Ott van egy kapcsolónk idejelölve.
Akkor vegyük a...
Installation of the pipes and wires before plastering started with the electrical system. All I had asked for at the design stage was that if a bulb blows in any room, it shouldn't cast the whole house into darkness. So practically every room or major consumption point has its own circuit breaker and a separate cable from the distribution board. In the meantime, I had stumbled on the ready-cabled French flexible conduit. Richie and his electrician crew couldn't see the point of it at first, but they soon changed their minds. All the cables you need are already drawn through the conduit in 100-meter rolls, be these 3 or 5-core television or telephone cables. It completely saves you the tiresome and risky operation of drawing the cables through. And those electricians particularly like being able to cut grooves in the walls so easily. The meter cabinet was installed at the same time in the outer wall of the garage. Before plastering, we wound the heating pipes onto the wall. These are embedded into a few millimetres of concrete in the ceiling and a centimetre of plaster on the wall. This heating system can be used in reverse, so you can cool the house in the summer for peanuts. It's child's play putting up the thin tubes. Unlike radiators, they take up no space in the room, and the warmth radiating from the wall simply feels good. There is no movement of air, which means no drafts, and the room feels warmer at a lower temperature, so you can heat 2 to 3 degrees lower. It is much quicker acting than underfloor heating, and that means even more energy savings. Since the plaster had to be applied to a polystyrene surface, we used a special primer so that it would stick. It is called Beton Contact and was originally used on concrete surfaces, but it works just as well on polystyrene. We had central vacuum cleaner tubes fitted into the walls and the floor. Breka had not wanted it, as she claimed ownership of the best vacuum cleaner in the world. But for me, the noise of hoovering is one thing that can drive me out of my own house. The central vacuum cleaner is quiet, sucks up the finest of dust and even pollen. And you can wash out the tubes, not a small point if you are afraid of fungus or bacteria setting up home there. The stairs are the product of a very special technique. Concrete was poured from a watering can between 1 centimetre thick plaster panels. The plaster immediately starts sucking the water out, resulting in the incredibly strong phenomenon of gypsum concrete, from which you can build just about anything. Since the plumbing team was otherwise engaged, Attila, to save time, decided to get the plastering done. I found a system as yet little used. Instead of the usual cement-based plastering material, it uses quick-setting gypsum. This has the same humidity-regulating effect as the partition walls. Plastering traditionally involves lots of wheelbarrow pushing, heaving buckets and splashing water so that everything gets covered with sand, lime and cement. Instead, we had 3 jolly fellows and a piece of precision machinery. They produce plaster of very even thickness and walls that are perfectly flat and smooth. A special membrane laid over the top of the living space reflects heat back into the house and keeps in the humidity. That stops any condensation in the exterior side, which could run back into the house, soaking the insulation along the way. It is glued to the top of the vertical walls, the sheets joined together with a special adhesive tape. Wherever it crossed a pipe or a screw, each tiny gap was closed with painstaking thoroughness. Installing the ventilation ducts was a sort of snake-charming act. Poor Mishy and his installers took on just a bit more than they had reckoned with. Originally, there were to be 5 centimetre PVC pipes buried in the inner polystyrene layer of the outer wall. The structure was already up when articles started to appear in the European trade press that it is inadvisable to lead fresh air in through PVC pipes. We were lost. We had to rethink the whole system. There was no room planned for the new 16 and 20 centimetre steel pipes. It caused Mishi a set of brain twisters to solve this that might still be spoiling his sleep in years to come. All the same, they put in an incredible effort to make sure the system would be perfectly quiet. There should be no sound of moving air, and neither should any noise get through the pipes from one room to another. The house was now sealed on all sides, and though we still had no roof insulation, it was time for the first trial, the blower door test. This is a compulsory measurement for passive houses and detects whether air can escape anywhere. If it does, the warmth goes with it. An enormous fan sucks the air out of the sealed building, and the computer connected to it measures how much the house leaks. According to Imre, the head of the company who does the measurement, an average Hungarian house lets out several times its own volume of air every hour. For us, if air more than 60% of the total volume escapes per hour through the gaps, it will not make the grade as a passive house. Our windows still needed adjusting, and the wind was whistling through the locks and unsealed gaps where pipes go through walls. Even so, the house only let out 68% of its volume. We could continue. We laid the roof insulation on a vapour barrier. It is usual to use some kind of panels for this, which are very good as long as the installer is very good. Occupants of new houses have often been heard to complain that water is getting in, when all that is happening is condensation running in from imperfect insulation. Our heat insulation, officially called cellulose fibre, is in fact recycled newspaper. It's a great invention, almost impossible to put it in wrong. The fibres are whipped up in a machine like a giant mixer, then blown through a tube under the roof, where all the installer has to do is check if it falls in an even thickness. The fibres get into every little nook and cranny, and since it's got borax mixed into it, which every living creature hates, neither beetle nor larger animal will be moving in. The drips on the vapour barrier soon disappeared after the insulation was in place. Having taken several thousand more litres of water into the house with the plaster, we had to let that dry too. It was the end of November, a time when building usually comes to a standstill, waiting for the wind and sunshine of spring to dry the building. But we were living in a rented cottage, which we had only got as a favour, and sooner or later we were going to have to move out. I found a device and a company which could suck the moisture out of the walls using only a minimum of heat energy. Very dry air is blown into the room, picks up the moisture and then deposits it inside the machine. For the next few weeks, we were carrying water out of the house by the bucket, but the work could carry on. The garage door arrived when it was still winter, but only started to work when the trees were in leaf. The controller is a little genius which learns the difficult sections of the door's travel so that it can optimize the power of the motor and save energy. The little door in the middle is a brilliant idea. It is now used as the front door of the house. The children had put in a demand for keys of their own as soon as we started building. I was not exactly keen, although I admit the key to the door is a symbol of personal freedom and independence. The answer was a neat little device, a fingerprint reader, which lets the whole family open the door independently, and nobody can lose the key. The plumbers could only start their work after the plastering was finished, and I nearly cried when they cut into the nice new wall to mount their pipes. Any time I have refurbished my home in the past, the removal of one tile inevitably led to changing all the old worn-out plumbing behind it. So this time I wanted durable pipes that will hopefully never have to change as long as I live. The toilet flush and washing machine use recycled wash water, which needs separate pipes, and the circulating hot water needs another 2 pipes. To keep the water in the pipes warm, the final step was to insulate every pipe and intersection. For the wash basins and toilets, we used a special frame that fits in front of the wall and holds the pipes, including the sound-insulated downpipe. The almost completely silent cistern is built into the toilet frame, so now we have no fear of being jolted out of bed every time somebody has a shower or pulls the flush. The other typical fault of downpipes is the smell, which can only be avoided by ventilating. In a passive house, no ventilation pipe can be led into the attic, so we chose an arrangement whereby the ventilation head can be hidden in the wall. The last but crucial stage of installation was the pressure test. The system is filled with water or compressed air, and a pressure meter checks if there are inadequate seals or leaks. What a relief to see there weren't any. Before laying the screed under the flooring, the house had to be insulated from below. There are 2 schools of passive house designers. One says it is unnecessary to insulate towards the soil. The other insists on just as thick insulation as on the walls. We laid 25 centimetres of polystyrene on the structural concrete and 5 centimetres sound damping panels on the floor between the 2 levels. The pipes supplying water to the wall heating also run under the floor, in a groove cut by a hot knife in the insulating polystyrene, so they are insulated too. A passive house needs to be airtight and proof against moisture at every point. So on top of the heat insulation, we put a membrane that seals against water from all directions. A 1 centimetre thick soft panel laid along the edge of the sheeting prevents problems if the screed moves because of heat or load, and also stops sound on the floor being transmitted. So someone could be tap dancing in studded boots in the room next door, and you might never know it. was brilliant sunshine without even the suggestion of snow when I ordered delivery of the screed, the layer that divides the flooring from the load-bearing structure and the insulation. And what happened the next day? The land was covered with a thick white carpet. It put us all to the test once again as we laboured to get the material into the house. I even got the Jeep out to try and pull the 30-ton lorry up the hill. Screed is normally made of concrete and smoothed with a float. We used gypsum. It was mixed to the consistency of cream by a machine in the garage and then pumped up to where it was needed. The gypsum screed levels out all by itself, and all the installer had to do was check the thickness with a level meter as it spread out, and then smooth the bubbles out with a special tool. It's a fabulously efficient procedure. In good circumstances, a 3-man team can lay 1,000 square meters of screed in one day. And incredibly, these thousands of liters of cream hardened 2 days later into a mirror-smooth surface you could walk on. The screed then had to be polished. The cursing to be heard from the workers was enough proof that this material is harder than strong concrete. Now it was time for the plasterboard panels on the ceiling fixed to a frame of battens suspended from the joists under the vapour barrier. We used plasterboard that produces moisture if it comes in contact with flame and inhibits the spread of any fire that might break out. The buried spot lamps were Rirka's request. We worked out we would need about 30 of them in the living room alone. So we had to find a way of stopping the heat developed by the lights from scorching the plastic sheeting above, not to mention the timber. We installed a special protective hood for every spotlight to stop the heat getting through. Just as the airtightness test detects any leaks into the outside atmosphere, the heat camera shows up imperfections in the insulation, possibly where mistakes have been made in installation. Eric looked as casual with his heat camera as if he was making a home video, but taking these pictures and making sense of them require a lot of expertise and experience. Insulating faults are a source of major problems, even in ordinary houses. The wall gets cold at the gaps, the moisture condenses, and the mould starts to form. But in a passive house, where it's absolutely crucial to stop heat getting out, every aspect of installation demands painstaking precision. It was a wonderful feeling to see these images, proof that the house keeps the warmth evenly at every point. The walls had dried quickly. We could paint. I thought this meant putting a bit of colour on the inside of the house. Well, there was slightly more to it than that. Polly, the painter, who turned out to be a bit obsessive, said anybody can roll paint onto a good surface, but if the plaster is not properly prepared, nobody can make it look right. So we had to wait some time before we saw any colour. The ceiling presented the least work. On the ground floor, the concrete surface formed by the mirror-smooth wooden shuttering only had some slight protrusions caused by the joints, and these were whisked off with a diamond sander. The upstairs ceiling was plasterboard, and here the joints were strengthened by glass fibre tape and plaster. Every surface, including the concrete ceiling, had to be primed before the finishing plaster went on. It's the primer that ensures perfect adhesion for all the other coats, And if you skimp on this operation, a short while later you can find your beautifully painted finish blistering off the surface. Before the top coat of plaster, the interior windowsills were installed, of course following the special and highly precise window insulation procedure for passive houses. I was horrified to see that angle grinder attacking the beautifully plastered window recesses. But it was all right. The painter smoothed out the saw marks, skimmed over the joints, and filled them with paintable acrylic. Then came the finishing plaster, or skim. Traditionally, the plaster is mixed in a bucket and skimmed on to smooth out imperfections. Polly has a special piece of equipment that sprays the plaster mixture at high pressure onto a prepared surface. This saves an enormous amount of work. Wherever plaster, plasterboard and plastered structural walls meet, the highly trained team of painters took extra special care. Different materials move differently, and to prevent any cracks from developing, they reinforced the joints with glass fibre tape and with sandable and paintable acrylic filler. A few hairline cracks appeared on the plaster, a natural development. Polly cut no corners. He covered every plastered surface with adhesive fiberglass fabric, a kind of strong wallpaper that covers any hair cracks. I thought he must put the paint on soon, but he said he would let nothing short of perfection out of his hands. He used 3 rather than 2 layers of finishing plaster and then got out a big floodlight and set it at a grazing angle that showed up the faults, he said. It was great good fortune that had brought me this crazed perfectionist. We had done a lot of research and we knew what paints we wanted to use. There are all kinds of special purpose paints, some right for bathrooms, different ones for bedrooms. We were desperate to see the paint on, but when the time came, no matter how much we had pored over colour charts, used the company's computer visualization program, we felt unsure about the colours. The most difficult was finding the right colour for the living room, where Reka and I finally reached agreement. But then one of the children put in a veto. At last we found the answer, the light eggshell colour of unbleached cambric. The work could start. We chose white paint for the kitchen and bathrooms. The little house we lived in during the building was mouldy. My son Oliver coughed long into the night because of it. The bathroom and kitchen always produces a lot of vapour, and despite the mechanical ventilation, we thought it best to do everything we could to keep mould out of our new house. So we used antifungal paint. We found special paint for the bedrooms with the amazing property that sun shining on it destroys any microorganisms that have settled there. It is like disinfecting the bedroom before you turn in to sleep. Painting the sauna room turned out a bit finicky. Polly probably wished us an even warmer place after it. He put on 11 separate coats to get the yellow patched roughened effect. But what we got in the end was a perfectly soothing, close to nature ambience. choice of flooring once again brought us up against the problem that there is hardly any right angle in the house. What I wanted to avoid was a standard square mesh of tiles that would jar with the slanting wall. That logically brought us to the stone carpet and the liquid floor. Both are based on synthetic resin, but the stone carpet has tiny stones mixed into it, and that thick paste is what forms the flooring. Little highlights can be scattered onto the surface of a liquid floor. This was the kind of synthetic resin floor we used in the garage. The utility room flooring is stone carpet. Here, tiny, bright yellow dyed stones are mixed into the resin. This is where we will be coming into the house in muddy clothes after hikes through the forest and games in the garden. The control gate where we take off our dirty clothes and throw them into the washing machine. Zolly and his mates laid a carpet that is as watertight as any tiles. In the two outer bathrooms, only one of the four corners is a right angle. I couldn't find a ready shower cabin and I didn't really want one. So we have a built-in shower tray with a waterproofing tape at the intersection of the vertical and horizontal surfaces. The gypsum wall and plaster also had to be protected from water under the tiles. The corners were also sealed with waterproof tape. The walls are covered with tiles nearly up to the ceiling. We chose big, plain earth-coloured tiles laid tightly together. They were fixed with waterproof tile adhesive. We found really fantastic tiles for one of the little bathrooms. This is an Italian product, still in its infancy. They are 3 millimeters thick, 1 meter wide and 3 meters long, and you can do almost anything with them. Tilers are said to be scared of it. They think it will break too easily. And I was the first person in Hungary to find a lion-hearted tiler who would take the risk of working with material the thickness of glass. To lessen his misery, I relented on the giant panels. What we used were factory-cut tiles in sizes 40 by 100 and 5 by 100 centimeters. I did not know that tiles still needed to be grouted, even if there was practically no space between them. And this, of course, meant flexible silicone grouting in the corners. This was the final water seal. To be absolutely certain of preventing water getting under the flooring, liquid sealing compound was applied to the floor under the shower trays. 2 of the 3 little bathrooms have stone carpet floors, which we also use for the base of the built-in shower cabins. After that, it took almost no time to dress the bathrooms up. The toilet bowls and wash basins are all pure white, but a slightly different style in each bathroom. The elegance and diversity of bathroom porcelain you can get is just amazing. All of the toilet bowls are wall-mounted, making it easier to clean underneath. I found one which has a special coating. It's called Wonder Gliss, and no dirt will stick to it. We use much less water to flush the toilet nowadays. Where there are 2 buttons, you let different amounts of water out of the cistern depending on what you have deposited, and if there is 1 button, you decide how long the water should flow. The bathrooms were too small for a bidet, however much we would have liked one. It is so hygienic and is even thought to prevent cancer of the bowel and rectum. So we put in a shower toilet, which not only dispenses with paper by washing your backside, it does it all by itself. You just press a button and let the warm water flow out of the nozzle. No hands. And it's a wonderful feeling. The choice of showers is also unbelievable. For children, it's important to have a thermostat to stop boiling hot water coming out of the shower head and a cooling mechanism to stop the tap getting too hot. We chose large shower heads that shoot out the water mixed with air and do so in all kinds of ways. Also a panel that massages with water from tiny shower heads jetting in every direction. For the built-in shower cabins, I found beautiful made-to-measure toughened glass doors. Some slide, others are on hinges. I could choose which way it should open and how many door panels it should have, and it has a special coating to stop the water leaving a mark. We looked for taps that are not just elegant and durable, they also had to be safe. We also found out that using the right tap can save a lot of water and also save on the energy to produce hot water. I had just one real weakness, a passion for the pure luxury of the steam bath and sauna. Heat that relaxes, soothes and comforts. Steam at 40 degrees, often perfumed with scented oil, has been valued since Roman times. This unit combines steam and shower functions, and using it is pure ecstasy. Another means of healthy relaxation is the hydro massage bath with its massaging water jets and tingly air bubbles. The multicoloured lights under the water add to the experience. The circular bath is not just beautiful to look at, the water in it is always fresh because it is made with special technology to prevent stagnant water. It also has safety valves that stop the pump sucking in hair or even a child's finger. The infra cabin, just like the traditional Finnish sauna, freshens and detoxifies. It is not as hot, 40 odd degrees rather than 100. The infrared rays penetrate several centimeters under the skin, producing sweat and eliminating toxins. It is much more energy efficient than the Finnish sauna, heating up in a short time and can even be installed in a bedroom. The electricians return to finish the wiring. Each wire has a separate label so that any future electrical work can be done without hours of complex detective work to find out which wire leads where. Each circuit has a separate protective switch in the distribution cabinet. The ground fault interrupter does more than protect against short circuits. It means no harm will be done even to a child who accidentally sticks a needle into a socket or touches a wet hairdryer. The distribution cabinet also contains an overvoltage trip to protect sensitive electronic equipment and little indicator lamps that show in case of power failure if the problem is within the house or not. The heart of the ventilation system found its place in the machine room. It controls the flow of outgoing and incoming air, so that the air going out of the house leaves nearly all its heat behind. The machine extracts used air from the kitchen, the bathrooms and the toilets, expelling it to the atmosphere, and blows fresh air into the other rooms. Air from the outside first passes through a 50-metre heat exchange pipe 2 metres underground. A filter on the inlet takes out the dust and allergy-causing pollens. Since the temperature around the pipe is always about 8 degrees, in the summer heat the air may cool down from 32 to about 20 degrees before entering the house, and in the winter it heats up from -15 to about 3 degrees. Inside the house, the fresh air takes on the heat of the used air via the heat exchanger and is then dispatched with another fan towards the rooms. The machine has minimal power consumption, but it keeps the air as fresh as if the window was open. To keep the air flowing freely, there is an 8 to 10 millimeter gap under the interior doors instead of the usual threshold. Also in the machine room is the geothermal heat pump, which provides our hot water and reserve heating should we need it. The heat pump sucks liquid at 3 to 8 degrees from deep underground. It is transferred to a refrigerant where pressure is applied so that its temperature goes up to 60 degrees. The heat so obtained goes to the walls and ceiling heating pipes and also heats up 250 litres of water in an insulated tank. In summer, if the house warms up, it can substitute for air conditioning. The water standing in the tank is never used for washing. Such a warm, wet environment is the favourite breeding ground for the highly dangerous Legionnaire bacteria, so it transfers its heat to the water in the pipe via another heat exchanger. The temperature of the water in the pipe is monitored and circulated by a little pump when necessary, so the water in the tap is always hot. Yet another item of equipment in the machine room is there to prevent build-up of scale. Scale is the biggest enemy of water pipes and machines that use water, and it also builds up on glass and taps. This device benefits from a field of science that has been making enormous progress: molecular nanotechnology. It needs no electricity. All you need to do is replace the filter every few years. The machine room is not very big, but there was still room for the pontos. This is a machine that imitates the way village people save water. If you wash your hands in a basin of water, you don't just throw it away. The pontos filters, disinfects and stores water that flows out of the wash basin, bath and shower and pumps it into the toilet cistern and washing machine whenever it is needed. This way we consume about half of the water an ordinary household would use. The central vacuum cleaner was installed in the box room. The machine starts up automatically whenever you put the suction tube into a vacuum socket on the wall. A powerful filter removes the dust from the air as it is sucked in. Smart little accessories make life so much easier, like the built-in dustpan to sweep any crumbs into. Before the portable toilet arrived, we never missed it. It is something of a novelty for the building of a family house, but it could just as well be mandatory. At one stroke, we avoid the dilemmas of leaving the site for half an hour, or postponing the matter, or shuffling away and discreetly disappearing behind a tree. Simple and civilized, and the company also keeps it clean. The interior of the house was resplendent by the time we started the exterior finishes. Since the house rises so steeply out of the hill, we wanted to somehow press it back into the ground. We asked Attila, who had a stunningly simple suggestion. Stone facing would make it look lower. We just had to reconcile a few points. It should have the appearance of a Mediterranean dry stone wall, be no more than 4 or 5 centimetres thick, and be the colour of stone in this area. To my great sorrow, the closest place we could find this was 200 kilometres away, but we didn't regret it. Before the final rendering on the outside wall, the roof soffit was made with pine floorboards. I have seen so many houses with rotting or sun-cracked soffits, and I resolved that this was going to be properly treated. I found a coloured timber preservative, which is antifungal, flame-resistant and light protective, so it gives all 3 protections in one. And to make sure the attic is properly ventilated, just as there is a vent running all along under the ridge, we sank a pierced stainless steel plate around the soffit. Before putting the finishing coat on the rendering, the outside windowsills made of beautiful Italian limestone were put in place. The heavy slabs were laid on flexible adhesive with different kinds of sealant at the joints with the rendering and the window cases. Just as with traditional rendering, the finishing coat is what gives the external wall insulation system its final appearance. We were again at the mercy of the elements. If it rained, it would of course wash off the thin outer coat, but if it was too hot, it would set too quickly and be unsightly. For 3 weeks, Polly and I looked up at the sky every morning. And another lesson. I wanted to keep the scaffolding up so that the tinsmith could finish his job, but Polly would not have it. Rain splashing off the scaffolding could have spoiled the fresh rendering. I wanted the gutters that drained the water running off the roof to stand up to the vicissitudes of the weather, just like the rest of the house. We looked at all the available materials and in the end went for titanium zinc. It is unmatched in terms of durability, it's easy to form, and its grey finish modestly blends in with the grey stones. It is a relatively big roof area, and so we put in 2 downpipes. To stop the expansion of the long gutter breaking any soldered joints, we put in some rubber expansion joints. A useful invention is the diverter, which lets you draw water directly from the downpipe. And just in case the drains smell, we fitted in an odour trap. The clean, soft rainwater off the roof collects in a concrete water tank we built in the garden, lined with waterproof renderings. If the water in the pontos runs out, we can pump water from the tank for the toilets and washing machine. If not needed, it can be used for watering and car washing. There is no sewer in the village. The prescribed arrangement in Hungary is the closed septic tank, which has to be emptied by truck. If I was to comply with this, it would cost a fortune. So we wanted a biological sewage treatment unit. Since we were building within a national park, we needed approval from the environmental authority as well as the local council. We found a system which does the initial purification in a single plastic tank. Industrious bacteria eat and digest every bit of organic material, so the whole wastewater that flows out of the tank after the preliminary treatment is sufficiently clean to water the plants and full of nutrients. Since the plot slopes towards the streets and the garden is to the back, we needed a heavy-duty pump to send the pre-treated wastewater to the highest point of the garden. The small amount of dry residue, if we are lucky, will only have to be pumped out every 2 or 3 years. The rooms in the house were still only half dressed. When it came to the flooring, we scratched our heads long and hard. We looked at countless different materials, and so that everybody could have what appealed to them, the floors are all different. Rebecca chose for her study a carpet of natural material, woven out of tropical grass sisal. For our bedroom with the bathroom, we looked for a moisture-tolerant material, opting in the end for a seagrass carpet and oiled ipe flooring under the bath, a similarly dense, water-resistant hardwood as teak. In the sound and video studio cum library, we laid an easily cleaned, sound-damping coconut fibre carpet. The flooring for the children's rooms took several attempts to decide. The criteria were, it should be warm, soft, not retain the dust, be easy to clean, be durable, and not require the children's playing to be unnecessarily restricted. These brought us to a version of cork flooring that is easy and quick to lay and needs no adhesive. An all-round success. All other floors, including the stairs, are floorboards of another tropical wood, merbau. Before laying the flooring, the entire surface of the gypsum screed had to be covered with a 2-component synthetic resin to stop the gypsum absorbing moisture. On top of this came flexible parquet adhesive, and the merbau was laid into this. Then came the sanding and the fine sanding, then the sealing. The gaps that inevitably occur here and there were filled with the finest sanding dust mixed with a special gel. I wanted to oil the wood, but Jolt defied all my protests and convinced me that wood flooring is much better protected by varnish. The primer coat produced a repulsive, if quickly dissipating vapour, but otherwise brought to life the wild forest colour of the wood. Then came the varnishing, sanding and varnishing again with very hard, tough, but thankfully water-based materials. And then we should have had the final coat, but Jolt said no. He said we could stamp our feet and shout, but he wanted to be the last tradesman in the house. Everybody would be walking on his work, and accidental damage could happen at any time. Rebecca complied. Jolt had himself invented a way of making skirting out of floorboards. We also found a special adhesive so that I would not have to look at screws for the rest of my life. When I asked when the interior doors would be coming, I got the answer that these are almost furniture, to be installed as the absolutely last item in a clean house without damage. Just like the exterior windows, these are made of Meranti pine. They were installed at a bewildering tempo and with perfect precision. I had never before given much thought to handles. They were just something you take hold of to open the door. I didn't know about the special keyless mechanism for bathroom doors, the way of matching the burglar-proof front door lock with the completely different shape of the interior handle, or the window handles with special ratchets that stop them being fiddled with from outside. It was fun to fit them. Even the children could do it. I have always liked that distinctive item of English interior design, the built-in wardrobe. Unexploited corners and nooks turn into storage space. There is no need for a separate mirror, and various natural materials like bamboo give the doors a friendly aspect. So there are built-in cupboards in every bedroom, a shoe cabinet in the hall, and a big, common walk-through closet with a mirror in the middle of the house. The stair handrail was made by a young craftsman with a real flair. He was the first person I saw using a special new tool. It fits easily into the hand and reaches into the tightest and deepest gaps and uses vibration to saw, chisel, file, sand, polish and cut. There is almost nothing it can't do, and to craftsman's standard. Gabor saved 3 days of finicky chiseling with it, and the vibratory movement prevents injury. It is widely used by people with all kinds of disabilities. I like doing jobs around the house, big and small, and so do my sons. For the workshop, I wanted a simple, versatile, tough storage system that I could load anything onto without it collapsing. I had long known of Dexian racks, but what I did not want was to spend days screwing screws. Then I found there is a new version with components that clip together easily. You can put them up in a blink. The original plans envisaged a master bedroom with 3 areas, a bathroom, a closet, and a somewhat tight bedroom. Reka abolished the partition walls, moved the closet to the side, and asked for a wash basin in the middle of the room. This is where we have the only bath in the house, very high quality, made of traditional thick steel plate, perfectly enameled. With the standing taps, the mirror and the lamps designed by Philip Stark, it is an adornment for the whole house. When we started to work out which electrical controls should go where, I never imagined we would end up with the most complicated spreadsheet of the whole project. There are at least 5 types of switch depending on whether they operate 1 or 2 circuits, and on the number of places it is possible to switch on a light. It fascinated our kids that you can put a tiny little indicator light into a switch. Then there are dimmer switches, switches with built-in motion sensors, radio control switches. I had to specify whether they should be put in bathrooms and toilets, whether they should have a cover, built-in child protection, lightning protection, and so on and so on. You can juggle with colours, shapes, and casing of different materials. The concealed lighting was installed in the false ceiling. The spotlights turn only 1/5 of the electrical energy into light, the rest becoming heat. For 30 spots, this is equivalent to 1/3 of the heat the whole house loses in the depths of winter. So if I switch on the living room lights on a summer evening, it will just about set my hair on fire. So I devised concealed lighting for the living room. Beside the wall, undercover, are warm-tone fluorescent tubes. These consume a fraction of the power of the spotlights and hardly generate any heat. We were having our cake and eating it, although it left the plasterboard installer with a somewhat complex constructional puzzle. It is the nightmare of anybody building a house that some installer will drill through a pipe or a cable in the wall. When it came to installing the multifarious ceiling lamps, the electricians had an ingenious device that assisted them in finding heating pipes, cables, and reinforcement bars. Is also our workplace. All computers and telephones work in a single system. Instead of a jungle of cables sprawling into the house, internet and telephone comes in via a single cable, where it is led into a rack system distribution cabinet. That is the central point from where identical cables branch out to computers and telephones, and it is what keeps everything in contact with everything else. Since we all use the telephone exchange program and various data, these are installed on a separate server. This handles the internet link and collects and records data of different kinds, like the alarm system and the temperature and humidity at various points in the house. Neither are the telephones the standard issue. We use IP phones, which can be used to speak to any other phones, fixed line or internet. The great advantage of the computer system is that every call can be made at the lowest possible tariff. We can speak to Australia, for example, for less than 4 euro cents a minute. The wireless alarm system is security and convenience in one. There was no need to make a sieve out of the house to take the cables, which is just as well because I only realised I would like a security system after the plastering. The motion and window sensors can be fitted anywhere in the house. It is much more than the usual alarm function. The sensor has facilities for listening to music and leaving messages to other family members, and it also acts as an alarm clock and radio. With the remote control, you can also control lights or items of electrical equipment anywhere in the house. Complementing the alarm system is a cable-based smoke alarm. It does more than detect a fire. It can take action too. If necessary, it starts up the siren or the fire extinguishing system. Both the intruder alarm and smoke alarm have a function for getting information on their status by telephone. In case of any incident, it informs the house owner as well as the authorities. The kitchen furniture took days to build. It was a coordinated project involving furniture installers, joiners, stonemasons, plumbers and electricians. I had always thought that the furniture of a kitchen dining room was mainly a matter of aesthetics. How wrong I was. There are so many tiny details you can't even see, or even if you can, you would never think to ask for, but turn out to be vitally important. Good, quality worktops sealed with ABS and metal. Furniture ironmongery that makes the cupboards strong and stable. Drawers that slide out noiselessly at one push so that everything in them is instantly to hand, even right at the back. Or doors that can be removed in one easy movement, opening up the interior for cleaning. And Janusz thought of little things that can make working in the kitchen a joy, like the surface under the hob, which is lower down and easier to use for kneading. Then there is the compost container built into the counter. You just sweep in potato skins right after peeling. The sink is also a working surface where everything is to hand. Chopping board, drainer, a tap with pull-out shower head. That is perfect for washing fruits and vegetables, which have their own basket. Another great convenience is the liquid soap dispenser. The unique feature of the induction hob is that it is mostly the food in the pan that heats up. You can use cast iron, steel, or specially made induction hob pans on it. Cooking takes a surprisingly short time and consumes much less energy. A passive house cannot have an ordinary extractor hood which discharges into the atmosphere. This powerful but quiet and energy-efficient hood has an active carbon filter which neutralizes cooking smells, and the steel filter takes the grease vapor out of the air, which returns the kitchen much cleaner. A tiny water filter fitted in the corner of the sink removes contamination, bacteria and chemicals from the mains water. The kitchen scale level with the worktop never gets in the way when you are not using it. The oven consumes ridiculously little energy, but works wonders all the same. Freka bakes pizzas and rolls that have you mouth-watering just at the sight of them. It is fan-assisted, so you can bake more than one course at once without worrying they will take on each other's aroma. What's more, it can even cook with steam, and that makes food tastier and more colourful and preserves most of the vitamins and minerals. The self-cleaning filter in the oven ensures that 80% of grease vapor is removed from the air before it gets out into the kitchen. The built-in bread bin made of clay stops bread from getting mouldy, but does not let it dry out. The bread slicer is perfectly stable and takes up no space on the counter because it fits into a little drawer. And as well as bread, it safely cuts vegetables, meat and salami. The front panel comes off, making it easy to clean the drawer. Inside the built-in refrigerator, the temperature and humidity is constant, and its energy consumption is only 3/4 of an average Class A refrigerator. This is no small matter, because refrigerators sometimes account for anything up to 1/3 of an average household electricity bill. The counter 10 or so centimeters lower down is just right for making pizzas. Not only does it squeeze the last drop of juice out of fruit and vegetables, this very slow-running fruit press preserves the vitamins and minerals, and special magnetic and infrared effects means that much less chemical material from the plants get into the juice, which stays fresh in the refrigerator for days. For children, this is health itself, and more importantly, lots of fun. The kitchen has come out with top marks. It's so easy to work here. We are surrounded by smart and very economical machines, and even our physical needs and the logical sequence of kitchen tasks were taken into account by Tomasz, our very thorough kitchen designer. Under the sink, we have a selective waste container that opens easily by foot. It has 4 separate compartments for paper, plastic, hazardous and other domestic waste. The dishwasher also saves energy and water. It even thinks for itself. It can analyze how many dishes are in it and how dirty they are, and it sets the program accordingly. So it uses only the energy and water it really needs. You might think I'm joking, but it uses less water than you would to wash up by hand, so we save money as well as time. We reached the end of a great adventure, an utterly exhausting 2 years, but full of amazing experiences and excitement. I met many, many great people and real experts on the way. Although in the end, we did not quite manage the annual heating energy consumption of less than 15 kilowatts per square meter that German standards demand for classification as a passive house, but the certified 23 kilowatts was very, very close. At 2007 prices, this means a monthly heating bill of less than 20 euros, and in energy crisis times,